Welcome back to my channel. Today we are going to be talking about multiplying polynomials. Alrighty, so we're going to start off with multiplying monomials, which is a one term times a one term. Then I'll show you how to multiply a monomial times any other polynomial, and then I want to show you a couple of methods on how to multiply. I want to show you how to distribute, how to use the box method, and also how to use the FOIL method. So let's get started. We have lots of examples to work. I'll take you through them one by one, and if you haven't already, make sure you hit that subscribe button, show some love. I usually say it at the end. I thought I said it at the beginning of the video today. And if you like this video, if it helps you in the end, and make sure you hit the like button. And anytime you have any questions, make sure you put them in the comments below, because I will respond. So for this first example, we want to multiply negative 8m to the 6 and negative 9n to the 6. So we have a monomial times a monomial. And so what we want to do is we want to multiply the numbers together first. So the negative 8 times the negative 9. And then you want to put any of the variables together that are the same. So m to the 6, well, there is no other m, so there's no other variable to include with that one. And then n to the 6, there is no other n, so we'll just write n to the 6 by itself. So the only thing we really end up multiplying here is the negative 8 and the negative 9, which gives us a positive 72. So we get 72 m to the 6, n to the 6. These cannot be combined because they're different variables. One is an m and one is an n. So this will be your final answer, 72 m to the 6, n to the 6. In example 2, we have a monomial times a polynomial with 4 terms. And so anytime you have a monomial times a polynomial of any size, what you want to do is distribute that monomial to every term inside these parentheses, or every term of the other polynomial. So I'm going to distribute this negative 8m to the third to the 4m to the third. So I'm multiplying that. That's a 3. Then I'm going to distribute this negative 8m to the third to the 3m squared. And I'm going to bring this plus sign down. So negative 8m to the third times 3m squared. Then I'm going to distribute this negative 8m to the third to the 2m. So plus negative 8m to the third times 2m. And then lastly, I'm going to distribute this negative 8m to the third to the minus 1. So the minus here, negative 8m to the third, and then the 1. So we end up multiplying this monomial times every term inside the parentheses. So when you multiply the numbers together. So here I'll multiply the negative 8 and the 4, which is a negative 32. And then both of these variables are the same, so they can be combined. So remember from your properties of exponents, when you multiply two variables that have the same base, and you want to combine them, what you have to do is add the exponents. That's the product rule. So this will become m to the 6, because 3 plus 3 is 6. So here, this positive and a negative, that becomes a negative. So you're doing a negative 8 times a 3, which is a negative 24. Or if that threw you off what I said about the positive and the negative becoming a negative, just think a negative 8 times a positive 3. That's a negative 24. Combine the exponents. So again, you're multiplying, so you'll use the product rule. So you'll add those exponents, and that will be m to the 5th. Multiply the negative 8 and the 2, and you get a negative 16. Combine the m's. That's m to the third times m. Now that m has an understood exponent of 1, so that would be 3 plus 1, which is m to the 4th power. Then you have a 2 negative. So you have a negative times a negative, which becomes a positive. So you have a positive 8 times a 1, which is a positive 8. So that'll be plus 8. And there's nothing else to combine that m to the third with, so that will stay m to the third. So your final answer will look like this. Negative 32 m to the 6 minus 24 m to the 5th minus 16 m to the 4th plus 8 m to the third. So that is what you get when you multiply negative 8m to the third times this polynomial. For example 3, we want to multiply m squared plus 5 times 4m to the third minus 2m squared plus 4m. So with this particular example, I want to show you how to multiply using, it's not really called distributive property, but it's sort of like distributive property, because what you're going to do is distribute each term of the first polynomial to each term, or to this polynomial. You're going to distribute each of these first terms of this first polynomial to this whole second polynomial. So what does that look like? I'm going to multiply m squared times this polynomial, and then I'm going to multiply 5 times this whole polynomial. So we will rewrite it like this: m squared times 4m to the third minus 2m squared plus 4m, and then that's a plus, so plus 5 times that whole polynomial as well. So essentially what we're doing, or what we're going to end up doing, is taking this term and multiplying it by everything in that second polynomial, and then taking this term and multiplying it by everything in that second polynomial. So now I'll just distribute this to each of those. So m squared times 4m to the third minus m squared times 2m squared, and I'm just bringing these signs down, so that's minus because I brought that down, and then plus m squared times 4m. So I've distributed m squared to each of those. Now I'm going to distribute 5 to each of these, so plus 5 times 4m to the third, I'm bringing that sign down, minus 5 times 2m squared, bringing that sign down, plus 5 times 4m. And so now what I want to do is I want to go through and multiply each of those. So there is no number to multiply with this 4, so that will just stay a 4. But when I multiply the variables, then I end up adding the exponents by the product rule. So this becomes m to the 5th power. There is no number to multiply with this 2, so the 2 stays out front. Combine the variables, m squared and m squared, add the variables, that becomes m to the 4th. There is no number to multiply with this 4, so that stays 4. Combine the variables, and that becomes m to the 3rd. Now I have a number to multiply with the 4, so 5 times 4 is 20, but there's nothing to combine with the m, so that stays m to the 3rd. Multiply the negative 5 and the 2, and that's negative 10. There's nothing to combine with the m, so just that stays m squared. And then 5 times 4 is 20, so that's 20m. And so now what I need to do is combine any like terms. So this is 4m to the 5th. There is no other m to the 5th, so that would stay 4m to the 5th. I like to underline when I've wrote each one down, that way I know I've taken care of all of them once I'm done. So negative 2m to the 4th, that's the only one with the power of 4. So my next exponent is 3. So I have these two that have an exponent of 3. And so that would be 24m to the 3rd. Once I combine those, 4 plus 20 is 24. This is the only one with the exponent of 2. So then I write minus 10m squared. And then this is the only one with the exponent of 1 plus 20m. So the only ones I end up combining were the m to the 3rds. Other than that, there was no other like terms. And so this would be my final solution: 4m to the 5th minus 2m to the 4th plus 24m to the 3rd minus 10m squared plus 20m. So this is how you will multiply using what I call the distributive method. For example 4, we want to multiply x to the 3rd plus 2x squared plus 4x plus 1 times 3x plus 5. Now, for this example, I want to show you how to use the box method. So with the box method, you create a box and you let one side, the columns, represent one polynomial. You let the other side, the rows, represent the other polynomial. So remember, rows go horizontally like this and columns go vertically like this. So when I draw my box, if I let this represent my rows, then that means, oh, now my marker stopped working all of a sudden. So that means I would have an x to the 3rd here, a 2x squared here, a 4x here, and a 1 here. That means I need to have 4 rows because there are 4 terms. So, and then my other polynomial has 2 terms, so I'll put that across the top, a 3x and a plus 5. So I should have 2 columns and 4 rows. So this is what my box will look like. Each row represents a term and each column represents a term of the other polynomial. And so now what I want to do is in each box, I want to represent the term that's on the top of it and the term that's to the left of it. So for this box, I'll multiply the 3x and the x to the 3rd. Well, there's no number to multiply with the 3, so that will stay 3. But I would need to combine my variables. So x to the 3rd times x, I will use the product rule and add the exponents together, and that will become x to the 4th. Here, 5 times x to the third is just 5x to the third. Here, 3x times 2x squared, so 3 times 2 is 6. Combine the exponents on the variable 2 plus 1, that'll become 3. Here, 5 times 2x squared is 10x squared. 4x times 3x, 4 times 3 is 12, and then combine the variables by adding the exponents, and you get x to the second. Here, 4x times 5, that'll just be 20x. 3x times 1 is 3x, and 5 times 1 is 5. So this is all the terms you get when you multiply these two, but now you need to combine like terms. And your like terms are usually going to be diagonal from each other if you set them up in descending order of the exponents. So as you can see, these are like terms, these are like terms, and these are also like terms. So this would give me, I only have this x to the fourth, 3x to the fourth, 6x to the third plus 5x to the third. That would be 11x to the third. So yes, I'm adding the results of each of these boxes. So all of these will be added. So unless it was a minus, a negative in front of 1, then you would subtract them. So 12x squared plus 10x squared will give me a 22x squared. And then 3x plus 20x will give me 23x. And then 5 is by itself, so plus 5. So this will be the result of multiplying those two polynomials. 3x to the fourth plus 11x to the third plus 22x squared plus 23x plus 5. That will be your final solution. So this is how you would use the box method. So many of you have learned how to multiply using the FOIL method. The FOIL method works, however, it only works when you're multiplying a binomial times a binomial, which means 2 terms times 2 terms. So if I had, say, a plus b times x plus y, then when you multiply this, the F stands for first. You multiply the first 2 in each set of parentheses, so the AX. The O stands for outer, which means you multiply the 2 things that are on the outside, which is the A and the Y. The I stands for inner, which means you multiply the 2 things that are on the inside, the B and the X. And the L stands for last, which means you multiply the 2 things that are last in each set of parentheses, the B and the Y. And so that's how you use the FOIL method. Again, the FOIL method only works when you're multiplying a binomial, 2 terms, times another binomial. So let's look at an example using the FOIL method. Example 5, we want to multiply x plus 8 times x minus 6. Notice it is a binomial times a binomial. Now you can use any of the other methods as well on this particular problem, the distributive or the box method. But just for the sake of me showing you how to do the FOIL method, we're going to use the FOIL method. So that means we're going to multiply the first 2 things in each parentheses, which is the x and the x. Then we're going to multiply the outer 2 things, the 2 things that are on the outside of the whole thing. So the x and the minus 6. So it will be plus x times negative 6. Then we multiply the inner 2 things. So the 8 and the x. And then we multiply the last 2 things in each parentheses, which is the 8 and the negative 6. And so x times x, you just add the exponents. That becomes x squared. X times negative 6 is negative 6x. 8 times x is 8x, and 8 times negative 6 is negative 48. And then you would combine any like terms, and your like terms are the negative 6x and the plus 8x. Negative 6x plus 8x is 2x. So this becomes x squared plus 2x minus 48. So that ends up being your final solution to multiplying that binomial. And so this is how you multiply polynomials. We looked at multiplying monomials. A monomial times a monomial, and then a monomial times any size polynomial. We looked at how to use the distributive method, also how to use the box method and the FOIL method. So you can use whichever one makes you feel comfortable, whichever one you like the best. That's why I'm showing you different ways so you can figure out what works for you. My favorite personally is the box method. I like the box method because it helps me to stay organized, and it helps me to, just organize all this chaos, because as you saw with the distributive method, you can end up with a lot of terms that you have to write out. So if you have any questions whatsoever, again, remember you can put them in the comments below and I will respond. And if you haven't already, subscribe to the channel. And thanks for tuning in. I will see you in the next video.